Welcome back, dear children. Now we will move to our next topic, that is about the formation of images. Okay. Now, if you're standing in front of a plain mirror, you can see yourself inside the mirror, isn't it? And that what you are seeing inside the mirror, that is actually your image. Okay. That is known as the image. So, object. When I'm standing in front of a mirror, myself can be considered as the object, and what is seen inside the mirror can be considered as the image. So that is the first thing what you have to keep in your mind. Okay, the object means who was standing in front of the mirror, and what is seen inside the mirror can be considered as the image. Now, how is this image formed? So when I'm standing in front of a mirror, I am not producing any light, but the light rays from the sun, if it is daytime from the sun, and if it is night, light rays from the bulb or the tube is falling on my body and it gets reflected, isn't it? So the light rays which are reflected from me is spread in all the directions. Now, if these light rays, the light rays spreading from an object, okay, it moves in all the directions, and if these light rays hits on a surface, if the light rays coming out from an object hits on a well polished surface such as a mirror, it gets reflected, isn't it? When it hits on a well polished surface, it gets reflected, and these reflected rays, in some cases, these reflected rays will meet at a point, or in some cases, it appear to meet at a point. And at that point, we will get the image. Okay? Light rays will be coming out of the object. It spreads in all the directions. When it hits on an object, it bounces back or it reflects, and the reflected rays meets at a point or appear to meet at a point, and at that point we will be getting the image. This is how image is formed, and we are having two different types of images. Okay, real image and virtual image. These are the two different types of images. So we are going to study about the differences between real image and virtual image. Real image means here the light rays after reflection actually meets or converges at a point. So the light rays coming from an object hits on a surface and gets reflected, and when these reflected rays actually meets at a point, you can call it as a real image. Okay. Instead of meeting at a point, if the light rays appear to come from a single point, we will call it as a virtual image. Okay. If the light rays after reflection meets at a single point, real image. If the light rays after reflection appears to come from a single point, we will call it as a virtual image. Now, in the case of real image, it will be always inverted. So, if I keep an object, this is a pen. So, if I keep an object in front of a mirror and if I get it as inverted, it will be a real image. Okay. So, that is the next point. Real image means it will be always inverted. Inverted means upside down. Now, virtual image means always erect. That means if I am keeping an object like this, then the image also will be like this. Then you can call it as a virtual image. Now, can you tell me which type of image you can see when you stand in front of a plain mirror? If you stand in front of a plain mirror, are you seeing yourself as in an upside down position? No, we are seeing it as such, isn't it? That means a plain mirror produces a virtual image. Okay. Now, if it is a real image, it can be caught on a screen. So, using the projectors and all, you can see the images that will be real. But the image which is seen inside a plain mirror is virtual image, and is it possible to catch it in on a wall the image which you see inside the mirror? No. That means virtual images cannot be caught on a screen. Okay. So, three main differences between real and virtual images. First one, real images are obtained when the light rays after reflection actually meets, whereas virtual images are formed when the light rays after reflection appear to come from a single point. Real image is always inverted, whereas virtual image is erect. Okay, so this we will say as inverted, and this will be always erect. Erect means straight. Then real images can be caught on a screen, whereas virtual images cannot be caught on a screen. So, is it clear about the differences? Okay. Now we will consider the image formation using a point object. Okay. How is image formed using a point object? So, for that, I am considering a plain mirror here. So, this is the silver coating and this side will be the reflecting surface. Okay. I have kept a point object here. What do you mean by a point object? A small object, isn't it? It can be considered as a point source. Already we learned about point source and extended source. Point source means it's a very small part. Extended means our tube light and all. How will we get a point source of light? From a torch. In front of a torch, if you keep a cardboard with a small hole, then the light coming through that small hole can be considered as a point source. So, I am considering a point source of light placed in front of a plain mirror. We will check how we will get the image. So, actually, when you keep an object here you will be getting, this is the inner part of the mirror. Okay. So, if you keep an object in front of a plain mirror, you can see the object or its image inside the mirror. Now, light rays will be moving in all the directions from this in order to draw or represent an image. If we draw all these light rays, we will be confused. So normally, in order to show the image formation, we will consider just two rays. Okay. So only two rays are needed in order to show the image formation. So many rays are coming out from this, but we are going to consider just two rays. Okay. So let this be the first ray which hits on the mirror. So since it is a ray, I should draw a straight line with the arrow mark. So it's compulsory that arrow mark should be there, else it won't be a ray. So when it hits on the mirror, what happens? It gets reflected. Now I am considering one more ray. Okay, one more ray. Why this ray is not here? So I draw it here. Just one more ray which hits on the surface. So this also gets reflected. This is the reflected ray. Now, the rays hitting on this mirror gets reflected. What I am going to do is just extending these two light rays in the backward direction. Okay. So, here these two light rays are extended in the backward direction. Then these two rays will meet at a point. And this will be our image. This is the object. Okay. So, light rays will be coming out in all the directions from the object. We have just considered two light rays. So, after the light rays coming from the object hits on the mirror, gets reflected. And now, here the reflected rays are not meeting at a point. It just gets reflected. And I have extended the light rays in the backward direction. That is why I have used dotted lines here. So when we are extending the light rays, we have to use dotted lines, else you will be using the straight lines. Okay. So I extended the rays backward, then it meets at a point, and at that point I will be getting the image. So what type of image is this? Are the reflected rays actually meeting? No. Here, these two are the reflected rays, and when we look from here, these two rays appear to come from this point. That means this is a virtual image. Okay, is it clear? Two rays are coming and hitting on the surface, gets reflected. These two reflected rays are not meeting by themselves. So I have extended it backward so it meets at a point and you are getting the image there. And what you can see, these two reflected rays appear to come from this point. So this is the virtual image. Okay, this is the image formation in the case of a point source. Similarly, you can show it in the case of an extended source. So, if it is an extended source, how can you show this? Here I have the mirror. Let this be the silver coating. So, if it is an extended source means, here I have drawn the extended source. Light rays will be coming out from each and every point of this body. So, I will be considering two rays coming from two ends. Okay, so first ray, after reflection it will go up. Then second ray, this also after reflection moves up. Similarly, from this end also light rays are coming. First ray, after reflection, then draw like this. Here I have to extend it. Okay, then only I can draw it properly. It's little bit difficult to draw this for extended source. So, it will go up. Another ray, after reflection, this also will go up. Now, we are extending these reflected rays in the backward direction. So, these two are the rays which came from this point. So, this is our first ray. Now, I am extending this in the backward direction. So, when we extend this in the backward direction, it meets at this point. Similarly, if we extend this, we are extending the two reflected rays from this point. So, this meets at a point. So this will be this part. Okay. Similarly, when you are extending these two rays, here also when you are extending, it meets at a point. Then when we join these two, we will get the image. This is how we will be getting the image in the case of an extended source. So it's difficult to draw directly. Okay, if we have a pen, a ruler and a pencil, it's clear. Actually, its position should be straight. Since it is drawn on the board, it's difficult. That is why it comes like this. But what you have to remember is the distance, this distance between the object and the mirror should be same as the distance between the mirror and the image. Okay, so this is how image is formed in the case of an extended source. If it is a point source, we'll be drawing two light rays from a single point, but in the case of an extended source, we'll be drawing it from the two ends of that object. Don't think that only four rays are coming out of it. Rays are coming from each and every point, but if you draw all the rays, it will be confusing. So we'll just consider two rays from one end and two rays from the other end. Then extend the reflected rays backward. It meets at a point and in between that you will be getting the image. Okay, so is it clear? Now the next one is about the position of the image. So that is not needed. Okay. Next one, what is given in your book is about the position of the image. It is not needed. Now we will move to the next one, that is lateral inversion. Do you know what is lateral inversion? Lateral inversion. When we stand in front of a plane mirror and lift our right hand, then what about the image? Image also will raise its hand, but the hand will be left, isn't it? If I stand in front of a mirror and if I raise my right hand, the image seen inside the mirror will raise its left hand. So always there is a change in the right side and left side between the object and the image in a plane mirror, and this is known as lateral inversion. Okay, so what is lateral inversion? The change in the right and left sides of the object and the image in a mirror can be called as lateral inversion. So here I have a mirror. So this is our reflecting side. If I keep a letter P here, how will the letter appear inside the mirror? It will come in the opposite direction, isn't it? So this change can be called as lateral inversion. And have you seen the board on an ambulance? How is it written? Board on an ambulance is written as a mirror image. Have you noticed that? And do you know what is the reason for that? So normally when an ambulance is coming, the vehicle in front of it will leave space for the ambulance to pass, isn't it? So the person driving a vehicle will be checking. He won't turn back and he will check. He will be viewing the vehicles coming from the back through the rear view mirror, isn't it? He will be viewing the vehicles through the rear view mirror. Then a mirror will always give lateral inversion. So directly when you read the board on an ambulance, it is difficult because it is a mirror image. But when you are looking through a rear view mirror, the driver can see that an ambulance is coming and he can give way for it. That is why in an ambulance, the name ambulance is given as a mirror image. Okay, so is it clear? For a person driving a vehicle, normally looks into the rear view mirror about the vehicles coming from the back, isn't it? So since the person is looking through the rear view mirror, he will be getting a mirror image. Since the word ambulance is written as a mirror image, the person driving the vehicle or the car can read it as ambulance itself and he can give way for the vehicle. That is why it is given as a mirror image. Now, the last portion of this section is about the characteristics of a plane mirror. It's very important. What are the characteristics of a plane mirror? So, now itself we learn few characteristics. First one, I told you in the case of a plane mirror, a virtual image is formed. In the case of image formation, I have shown you. The rays after reflection actually won't meet at a point. We are extending it in the backward direction and then the reflected rays appear to come from a single point. That means what type of image is formed here? Virtual image. Okay. Now, what is the specialty of virtual image? It will be always erect. When you stand in front of a plane mirror, you will see yourself as such, not in an upside down manner. That means it is erect. Now, the third one what we learned is lateral inversion. If you raise your right hand, the image will raise its left hand, isn't it? So, lateral inversion is shown by a plane mirror. Now, the next one. The distance between the object and the mirror will be always same as the distance between the mirror and the image. If I am standing at a distance of 3 meters in front of a mirror, the distance between the mirror and the image also will be 3 meters. This is our mirror. We are considering a person standing at a distance of 3 meters in front of the mirror. Now, an image will be formed inside the mirror and this image also will be at a distance of 3 meters. Okay, so these are the 4 main points what you have to remember about a plane mirror. Which are they? Image formed is virtual and erect. It shows lateral inversion. The distance between the object and the mirror is same as the distance between the image and the mirror. Okay, so is it clear about the characteristics of a plane mirror? Then One more thing you can say, it is of same size. Actually, in your textbook, they have written it as of same size, but this is our actual point. Okay, same size or the distance remains the same. So you can add that point also. Object and image will be having same size. Clear? Now you can take page number 153 in your textbook. Exercise 7A. 17 question answers are there, and for few questions answers are there. No need to copy those questions. Rest you have to write. Okay. No need to copy the question. Just find the answer, write the answer. And next class during the Google Meet, I will be asking questions. Then only I can move to the next part, because you should be thorough with this. This is the fundamentals which comes in the case of a mirror. So is it clear, children? So write the lecture note, write the answers for the questions. Okay, thank you.